Everyone thinks space is a vast, empty void. They're catastrophically wrong. Far from being empty, the orbital highways above our planet are becoming increasingly congested, not with new satellites, but with a growing cloud of discarded rocket stages, defunct spacecraft, and millions of tiny, dangerous fragments. It's an invisible minefield, and it's getting worse. This isn't some distant problem for future generations. The danger is immediate and escalating. Every launch, every satellite deployment, every test of anti-satellite weapons adds to this cosmic junkyard, increasing the odds of a catastrophic collision. To understand the scale of this threat, consider this. The European Space Agency estimates there are over 36,500 pieces of space debris larger than 10 centimeters. That's roughly the size of a softball, but the problem isn't just the big stuff. There are an estimated 1 million pieces between 1 and 10 centimeters, and a staggering 130 million objects smaller than a centimeter. Even a paint chip, traveling at orbital velocities of up to 17,500 miles per hour, can deliver the impact force of a hand grenade. This wasn't always the case. For decades, space was a frontier. The early missions, Sputnik, Apollo, Skylab, left their mark, but the sheer volume was manageable. The real turning point came in the late 20th and early 21st centuries. One of the earliest and most significant debris-generating events was the 2007 Chinese anti-satellite missile test. A defunct weather satellite, Fengyun 1C, was intentionally destroyed. The result? Over 3,000 trackable pieces of debris. Just 2 years later, in 2009, came the Iridium Cosmos collision. An active Iridium communications satellite collided with a defunct Russian Cosmos 2251 military satellite. This wasn't an intentional act, but an unavoidable accident. The impact occurred at nearly 26,000 miles per hour, creating thousands more fragments. These two events alone significantly altered the risk profile of low Earth orbit, demonstrating the destructive cascade effect known as the Kessler syndrome. Donald J. Kessler, a NASA scientist, first theorized this scenario in 1978. He predicted that once the density of objects in LEO reaches a critical threshold, a chain reaction of collisions could occur, making parts of space unusable for centuries. We're not quite at full Kessler syndrome yet, but we're undeniably on the path. The consequences of unchecked debris growth are dire. Imagine a world without GPS, without global weather forecasting, without reliable satellite communication. These aren't just conveniences, they are critical infrastructure for modern life, for disaster response, for economic stability, and for national security. A major loss of orbital assets would cripple our interconnected world. The International Space Station, a marvel of human ingenuity, regularly performs debris avoidance maneuvers. Since 1999, it has had to adjust its orbit over 30 times to dodge potentially catastrophic impacts. Each maneuver burns precious fuel and time. Astronauts embarking on spacewalks face constant risk. Even tiny fragments can puncture pressure suits or damage sensitive equipment. A micrometeoroid impact on the Shuttle Challenger's window in 1983 left a significant chip, a stark reminder of the danger. So what's being done? The race to clean up space debris is gaining momentum, driven by a mix of international cooperation, innovative engineering, and sheer necessity. It's a challenge unlike any other. One approach involves tracking. Global networks of radars and telescopes constantly monitor objects in orbit, creating detailed catalogs. This data is vital for predicting collisions and planning avoidance maneuvers. But tracking only mitigates the risk. It doesn't remove the debris. That's where active debris removal, or ADR, comes in. Companies and agencies are developing audacious plans to physically deorbit or capture space junk. One concept is the space net. Imagine a satellite deploying a large net to ensnare a piece of debris, then dragging it into Earth's atmosphere to burn up. Clear Space 1 An ESA mission aims to do just that by 2025. Another idea is the harpoon. A satellite could fire a barbed harpoon into a piece of defunct rocket stage, then use a tether to pull it out of orbit. This requires precise targeting and robust engineering. Then there are magnetic tow systems, which would use powerful electromagnets to grab non-magnetic debris, or even laser brooms that would use ground-based lasers to gently nudge small debris into lower orbits where it can naturally decay. Beyond active removal, prevention is key. New design for demise guidelines encourage manufacturers to build satellites that will safely disintegrate upon re-entry, and deorbiting mechanisms are becoming standard, ensuring satellites can be retired responsibly. International collaboration is crucial. The United Nations Committee on the Peaceful Uses of Outer Space, or COPUOS, works to establish guidelines for sustainable space activities. It's a complex diplomatic dance, balancing national interests with global responsibility. The future of space exploration, scientific discovery, and our reliance on orbital technologies hinges on our ability to manage this growing threat. The invisible bullets above our heads demand our attention and our ingenuity. It's a race against time, a cleanup operation on an unprecedented scale to preserve the final frontier for generations to come. To explore another hidden danger lurking in the cosmos, watch our next video on rogue black holes.